Bismillahirrahmanirrahim. This video is another one from step response of an RL series circuit, and this is on the request of a student from Germany. The question is that this is the circuit, the switch is open right now, at t is equal to 0 this will be closed, and we have to find these 5 parameters. So let's recall. Now before solving this question, let's just recall what we have learned about the step response of RL circuit. This is a circuit when switch is on, voltage is applied, and we had found out the complete response or the general equation I may call given by this formula, where IT is the current at any time t. I infinity, as we have learned, that when the circuit is closed for a very long time. I0 is just before the closure of the switch or just after the closure of the switch. That means I0 minus or I0 plus, same. And minus again I infinity e raised to the power t over tau, where tau is L over R in case of a RL circuit. Now, two things we have to find from here. One is the I0, that is the initial inductor current. Now remember, in case of an inductor, we don't write IL0. It should be written actually, I feel. But anyway, this is a common practice that whenever we say I0, that means it is the, or I, it is inductor current. And then we also have to find the final inductor current for t greater than 0. And at any time in between, it will be this type of a formula. That means we have to have e raised to the power minus t over tau. So this is the formula that will carry for this circuit as well. Now the first question was to find ILT0 plus. Now ILT0 plus, I hope you know the concept that before switch is closed, we call it I0 minus, and the moment switch is closed, that is called a T0 plus. And in case of an inductor, we know that the current does not change instantaneously. So whatever is the current at IT0 minus, it will be same at IT0 plus. Now in this circuit, at t less than 0, this is open, so that means no current is flowing through the inductor. Therefore, we can say that ILT0 minus is equal to 0. And as we also discussed that the inductor current does not change instantaneously, that means ILT0 plus will be equal to ILT0 minus. And ILT0 minus is 0, that means ILT0 plus will also be 0. So this is the answer of the first question. Now we come to the second question, and here he has asked ILT, that means IT, as we mentioned here, current at any time t. So we'll need to calculate now I0, which we have already calculated to be 0. Now we need to calculate I infinity. And so for that, this circuit is now closed and time is greater than 0. Inductor will now behave like a short circuit. So for this circuit, we have to calculate this current IL. Now, what will be that current? Let's see. First of all, this we are calling it as I infinity. So we have to calculate I infinity, because now that the time is infinity, therefore this current will be called I infinity. And now from here, if you look, what is I infinity? This current is the source current I0 dividing into two parts. So by current division rule, I infinity will be total current divided by total resistance, all three adding, and multiplied by opposite arm. So we are finding current in this, and this is the opposite arm. So it will be multiplied by R1 plus R2. So this is I infinity. And now we'll use this equation. So ILT, which we call simply IT, is I infinity, and this formula, we know this is 0, we have found this value. Let's simplify this. ILT is 0, so we'll put that here. So this will be now putting 0 and simplifying. Now we get this equation in terms of I infinity 1 minus e raised to the power minus t over tau. Now I infinity we have already calculated, so we'll put that, but we don't know the time constant tau. Now what is tau? For RL circuit, the tau is L divided by R Thevenin or R equivalent. So we have to first of all find R Thevenin from this circuit. So next slide. Okay, so this we had found the equation for ILT. This was I infinity, and this is the formula for L R Thevenin. Now we need to find. Now for R Thevenin, you know that the source has to be made 0. Therefore, this current source is open circuited, and we look from the inductor. So our I is here, and we are looking from here. So we'll see all these three in series. That means R Thevenin is R1 plus R2 plus R3. So we'll use that here. So tau will be L divided by R1 plus R2 plus R3. And now we are ready to finalize this equation. So putting the value of I infinity, putting the value of tau. We have just written it in this manner, but tau we have written it separately to keep it neat. And just rearranging, so ILT will be this equation. Okay, now the third question was to find UAT or VAT. In the German question it is UAT, we call it VAT. So we'll find VAT and be very careful. How can we find this voltage? We have to mark this point here and this point here. Let's call it A and B. So we have to find VA and also VB. So VA minus VB will be this voltage. So VAT is actually VA minus VB. VA we can find by the voltage division rule from here, or by current. Now what is the current? Very important in this branch. This is the total current. This current we know is ILT. Therefore the current through here will be I0 minus ILT. And I0 minus ILT, this current multiplied by R2 will give VA. So VA is R2 multiplied by current in that branch. What about VB? We know that the voltage across the inductor is written as VLT, which is equal to LDI LDT. So LDI LDT. This remains same. IL, now we use this, we replace this here and differentiate this part. So this constant comes out, differentiating only the part containing T. And when you differentiate this, A constant will be 0, then minus, and minus, this will be plus, and the 1 over tau will come out. So we get this term. I hope you can follow this. And so rearranging, this is our final equation for the voltage VAT or UAT. Then is the energy. We know the formula for energy stored in a coil is half Li square, so Li or IT square. we have this value of ILT, so we'll substitute that, so square of that, and so this is our total energy. Now the next question, or the last question, is energy at T is equal to infinity. So in this, actually what we need to do is put T is equal to infinity. So limit this, limit T is equal to infinity, this. So limit T is equal to infinity, we just wrote this one. And simplifying, we're putting infinity here in place of a T. And I hope you know that e raised to the power minus infinity means actually 1 over e raised to the power infinity. E raised to the power infinity is actually infinity, and anything divided by infinity is 0. So this portion will be equal to 0. So this is 0, and simplifying, we get this to be our final answer. So I hope you have been able to follow this. Thank you.